Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering at MLR Institute of Technology. So in this video lecture, I am going to discuss about the star to delta and delta to star transformation. So in that we need to discuss about the what is the definition of the star and what is the definition of the delta, and also we have to derive the star to delta and delta to star transformation. So here the definition of the star. So star is nothing but any three elements are connected at single node point, we can call it as a star. So here the representation of the star is, it is look like Y, or we can also write star and T. So this is the representation of the star. So in terms of the resistor, here is the star connection. Let us take as this is A point and this is B point and this is C point. Now at A point this is RA, at B point resistor RB, at C point this is resistor RC. Here is the star. Now in terms of Y, look like Y only. So here also this is A point, B point and this is C point. Now here also the same thing. At A point we are having resistor RA, at B point we are having resistor RB, at C point resistor is RC. So star or Y. And in terms of T, so here also looking like T only. So this is the T network. So this is A point, let us take as A point, B point and C point, and resistor is RA and this is RB and this is RC. At C point we are having RC. So here the definition of the star connection is the any three elements, that is RA, RB and RC. The three elements are connected at single node point. We can call it as a star connection, right? So the star connection is represented by Y connection, reverse of Y and T network. This is the representation of the star connection. Okay. So now we are having this. So this is about the star. Now what is meant by delta? So here is the delta. So delta is nothing but the three elements are connected together. We can call it as a delta connection. Okay. The three elements are connected together. We can call it as a delta. So here the representation of the delta is, it is look like delta and pi. Here is the representation of the delta connection. So here in terms of delta, so we need to draw the circuit here. It is also looking like delta only. So this is, let us take as A point and this is B point and this is C point. Now here the resistance between the A and B is there. So we can call it as a RAB. So RAB is nothing but the resistance between the A and B. And here the resistance between the B and C is there. So this is RBC. Now the resistance between the C and A is RCA. Okay. So here is the delta connection. Now similarly we are having the pi network. So the pi network is, it is also looking like a pi. So here is the pi network and it is grounded, and here is A point, B point and here is the C point. Now here also we are having three resistors. The resistor between the AB is there, BC is there and CA is there. So the resistance between the A and B, we can write it as a RAB. The resistance between the B and C, RBC is there. Resistance between the C and A, RCA is there. Okay, this is the representation of the delta connection. Okay, so here delta connection is nothing but the three elements are connected together. We can call it as a delta. So it is represented by delta and pi, and here is the circuit symbol, that is delta, and here is the pi. So this is about the delta. Now in this star to delta and delta to star, we are having one derivation. So here is the derivation of the delta to star transformation. So here delta to star transformation is nothing but by using the delta values, we have to find out the star values. So delta values are RAB, RBC and RCA, and star values are nothing but RA, RB and RC. Okay. So here the delta values. So before that, first we have to draw the circuit here. So delta. So this is A, this is B, and here is C. So the resistance between the AB, RAB, BC, RBC, CA, RCA. This we can convert it into the star. So already we know the star connection symbol. So here is the star. So this is A, B and C. So this is RA, RB and this is RC. Now what we need to do? So by using these delta values, we have to calculate the star. Is nothing but delta to star transformation. So for that, we need to insert this star connection. We need to insert this star connection in the middle of the delta. We need to insert this star connection in the middle of delta. So here I am assigning star in the middle of the delta here. So here is the star. So at A point, resistor RA, at B point, resistor RB, at C point, resistor RC. Now we need to write the equations. Okay. For example, suppose here we are having the one source here. In between A and B we are having the source. Let us assume. So in that we have to eliminate this C term. Means there is no RC network. So then RA and RB, these two are connected in series. It is a series combination. When we are eliminating this RC, RA and RP, these two are connected in series. Means if any two resistors are connected in series, the equation is RA plus RB. That is equal to, now here we are having the source. Then RAB in parallel with RBC and RCA. So RAB is in parallel with RBC and RCA. So here means RAB. So these two are in parallel, means it is a series connection. RBC and RCA, these two are in series. So means RAB into RBC plus RCA divided by RAB plus RBC plus RCA. Let us take as equation number 1. Here is the first equation. Now the second equation. Now let us assume in between B and C we are having the source here. Then we have to eliminate A value. So then we have to eliminate A, means there is no RA resistor. So RA should be 0. Then RB and RC, these two are connected in series. So then RB plus RC equal to, so RB plus RC, that is equal to, so RBC in parallel with RCA and RAB, means RAB and RCA, these two are connected in series parallel with RBC. So then we can write like this: RBC in parallel with RAB plus RCA divided by RAB plus RBC plus RCA. Let us take as equation number 2. Similarly, let us take A and C. So in between A and C, let us assume we are having one source. Then we have to eliminate the B term. So means there is no RB value. Now RA and RC, these two are connected in series. So here RC plus RA, that is equal to, so RCA is parallel with these two. So RCA into RAB plus RBC divided by RAB plus RBC plus RCA. Let us take as equation number 3. So now we are having the three equations. RA plus RB equal to RAB into RBC plus RCA divided by RAB plus RBC plus RCA, and similarly RC plus RA equal to RCA into RAB plus RBC divided by RAB plus RBC plus RCA, right? So here we are having the three equations. Now we need to add equation 1, 2, 3. So here now we can add equation 1, equation 2 and equation 3. So here add equation 1 plus 2 plus 3. So then we'll get RA plus RB plus RB plus RC plus RC plus RA is nothing but RA, 2 RA is there, RB, 2 RB is there, RC and RC, 2 RC is there, means in that 2 is the common term. So 2 into RA plus RB plus RC, that is equal to, so here also RAB, RBC. So take LCM here. So we'll get RAB plus RBC plus RCA. So here RAB into RBC is there. Here also RAB into RBC is there. So 2 RAB RBC. So in that also we have to take the common term 2 into RAB RBC plus RBC RCA plus RCA RAB. So we'll get equation like this. Now here 2 is there. So this 2 and this 2 get cancelled. Okay. So now, so here also 2 and here also 2 get cancelled. So now let us take as equation number 4. Now if we can do equation 4 minus equation 1, if we can do equation 4 minus 1, so we'll get RC value. So RC equal to, so here is the equation, RBC into RCA divided by RAB plus RBC plus RCA star value. So we are getting one star value here. Now if we can do equation 4 minus equation 2, if you can do equation 4 minus equation 2, we'll get RA value. So RA equal to RAB into RCA divided by RAB plus RBC plus RCA. Similarly, so here is the another star value. Similarly, if you can do equation 4 minus equation 3, if you can do equation 4 minus 3, we'll get RB value. So RB equal to RAB into RBC divided by RAB plus RBC plus RC. These are the star value. So here is the derivation of the delta to star transformation. So in that we are getting the first one, RC equal to RAB into RCA divided by RAB plus RBC plus RCA, and next one is RA equal to RAB into RCA divided by RAB plus RBC plus RCA, and third one RB, that is equal to, so we are getting RAB into RBC divided by RAB plus RBC plus RCA. So these are the star values. So by using delta, here is the derivation of star values like RA, here is RA, here is RB, and here is RC. Right. So here, for example, I am taking the one simple circuit. So I am taking the delta network here. So this is A, B, and C. So this is 1 ohm, this is 2 ohm, and this is 3 ohm. Now this we can convert it into the star. Here is the question. So this is A point RA, at B point RB, at C point RC. So now we have to calculate the RA value. So RA equal to, so already we know the equation, RA equal to RAB into RCA. So RAB means 1 into RCA. So RCA means 3 divided by RAB plus RBC plus RCA, means 1 plus 2 plus 3, that is equal to, so 3 divided by 6, 1 by 2, so 0.5 ohm. So first star value RA equal to 0.5 ohm. And next one RB. So RB equal to, so we know the equation, RB equal to RAB into RBC. So RAB is 1, RBC is 2 divided by 1 plus 2 plus 3, that is equal to 2 by 6, that equal to 1 by 3, so 0.33 ohms RB value. Similarly RC is there. So RC equal to, so 3 into 2 divided by 1 plus 2 plus 3, that is equal to 6 by 6, that equal to 1 ohm. So these are the star values, RA, RB, and RC. So RA equal to 0.5 ohm and RB equal to 0.33 ohm and RC is 1 ohm. Okay. So here is the delta to star transformation. So if it is a star to delta, suppose if it is a star to delta, so star to delta transformation also we are having the same procedure, but the equations, so directly I am taking the equations here. So by using the star values we have to find out the delta, means the delta values are RAB, RBC and RCA. So RAB equal to, will get equation like this, RAB equal to RA plus RB plus RA RB divided by RC. Here is the RAB. Similarly RBC, another delta, RBC equal to RB plus RC plus RB RC, RB into RC divided by RA. So RBC value. Similarly RCA equal to RC plus RA plus RC RA divided by RB. Here is the star to delta equations. Okay. So delta to star means RA equal to RAB into RCA divided by RAB plus RBC plus RCA, and RB equal to RBC into RAB divided by RAB plus RBC plus RCA, and RC equal to RBC into RCA divided by RAB plus RBC plus RCA. So that is delta to star, and in star to delta, RAB equal to RA plus RB plus RA RB divided by RC, and RBC equal to RB plus RC plus RB RC divided by RA, and last one RCA equal to RC plus RA plus RC RA divided by RB. Okay. So here in the star to delta and delta to star equations also we are having so many problems. So in that, here I am taking the one problem here. So here we are having the one complex circuit. So in that circuit we have to calculate the resistance between the A and B, right? So in this, first we have to find out which elements are in delta connection or which elements are in star connection. So you can see here 3 ohm, 6 ohm, 6 ohm is there. So here 3 ohm, 6 ohm and 6 ohm, it is a delta connection. In this delta connection, we have to apply the star. We have to apply the star connection like this. Then we'll get star value here and star value here and star value here. After that we will go for the series and parallel combination. Then we'll get the resistance between the RAB. Okay. Here is the star to delta and delta to star transformation. Okay. So thank you one and all.